So computers wouldn't be very good if they couldn't compute, and Java wouldn't be very good computer language if it wasn't able to do math. And it can do math, so let's take a look. If we say int x equals 5 plus 6, like so, I'm going to use the print command to show you what this becomes. Print.out.println like so. X, let's print the x variable out. Press play. Here we get 11. 5 plus 6 is indeed 11. Java can do all kinds of math things like this. Let's say int y equals 6 minus 7. Let's try and print y. What's going to happen? We're going to get minus 1. There it is, minus 1. What else could we do with this? We could go int z equals 7 times 8. What's it going to give us? Let's try and print z now. There we go, 56. So it's working. It's able to do basic math expressions, and you've got the plus, the minus sign, the times sign. Now, there's something special about division that I want to get into, especially, and this has to do with the type of the, it has to do with the types that you're working with. Remember how we went over primitive types, integers and doubles? It comes into play here. So we're going to make int example equal 6 divided by 7. What are you going to get? You can't get a decimal because it's an integer. So if I press play, oops, let me just print out example instead of printing out z. If I press play, here I get 0. Why? Well, because this is integer division, and this is the kind of division you used to do when you were much younger. The way that this works is you're asking it, when you're doing an integer division, how many times does 7 fit into 6? And the answer in this case is 0. You cannot fit 7 into 6 any times because 6 is smaller. There's another math expression with sort of the opposite of division, but not really, and that is the modulo, like this. So the percent sign can be used as modulo, and what this does is it gives you the remainder in an integer division situation. So 6 modulo 7 is remainder 6. Just to kind of like push this point forward, if I use 8, what you would expect is that you can fit 7 into 8 one time, and then there will be 1 left over, just like division you did when you were much younger, long division. Now, we don't always want to do this though. We don't want to use integer division. Instead, we might want to use decimal division. So we can use decimal types, and we know that decimal types are doubles. So let's say double decimal equals 7 divided by 8. What's going to happen here? What's the answer you're going to get? Well, it's 0. It might not be what you expected. And that is because when you type a number just as a whole number like this, it considers it an integer type. So even though you've made a double variable, a variable decimal of type double, it's using 7 and 8 as integers. It's doing the math with those integers, and then it's converting the answer into a double for you. The trick to make this work with decimals is to give one number 0.0. And this means that this is of type double now. It's a decimal number, but it is 7.0. If I press play, okay, we saved it. We should get, oops. Oh, no. There we are. So we got it. I know that that was a mess up. Let's see what happens here. So just to prove to you, 7 divided by 8 does make it integers. It just does give you 0. But if you put 0.0 next to the 7, you're going to do some decimal calculations. And that's really all I want to tell you about math, except that we do have the order of operations. So if I say int order equals 7 plus 8 minus 2 times 6, order of operations is going to occur, and 2 times 6 will happen before the rest of it. So we're going to get 12 minus 8, that's minus 4. So this should end up being 3. So let's print out order and see what happens. Print, we get the number 3. Order of operations occurred. That's all for now, guys. If you want to see more student-made content or more tutorials, make sure to check out the TVM YouTube channel. I'll see you next time.